Okay, so let's look at how we can determine the domain and the range of a function that is given. And once again, we are simply talking about functions of several variables. Okay, so one thing that we have to understand is that the domain is just a set of values for which the function that you're given is valid for. Okay, so the set of values that you have that makes the function to be valid is simply called the domain. For example, if I talk about 1 over let me say 1 over x squared, mm, let me say minus 4. Okay, so when you look at the denominator there, this will give us the domain. We are going to say, okay, the denominator x squared minus 4 should not be 0. Okay, should not be 0. So meaning you're saying your x squared should not be positive 4, of which your x should not be what, positive or negative 2. Okay, so that's simply the domain. So what it means is that among all sets of values that you can have, like among all the values that you can have, like let me say from negative infinity, then you reach at negative 2, union from negative 2 to 2, union from 2 to positive infinity. Okay, so the set of values between negative 2 and positive 2 makes the function to be valid, and the set of values between negative infinity to negative 2, it makes the function to be valid, and the set of values from positive 2 to positive infinity, it also makes the function to be valid. But if I pick negative 2 or positive 2 itself, I'm going to find that it's invalid because 2 and negative 2 are simply not part of the domain. So the domain just simply tells us that it gives us a set of values that makes the function that you're given to be valid. All right. So we'll go through some examples. Then for the range is just more like the output of the input. So it's more like um, the domain will give us the input in here. Then the output is going to be what? The output is going to be the range there. Okay. So let's look at this first example. Let's say we're given f of xy. Let's say is equals to the square root of x squared minus y squared, like that. So we want to determine the domain and the range of that function. So one thing that we you clearly observe even as you start to solve the question is that we know this is a radical function. Okay, and we know to say for such, since I'm talking about a square root, remember to say roots are more like you have n here. So this n can be an odd number or it can even number. What I mean is that it can be 2, it can be 3, it can be 4, it can be 5, but in this case let me just use 2 and 3 as an example. So this can be a square root. Here there is a 2, but we don't just put it. In most cases we just write like that. That means square root. Then the third root is like that. Okay, so what we get for this one and what we get for this one, they are two different things. Okay, so when it comes to a root, we really need to be careful to, like, when you're determining the domain, because if you know to say, okay, I'm dealing with an, like, maybe a third root of which is we are dealing with an odd number, the domain is different from when it from like as if it was a square root, such as like we have a 2 is an even number, or maybe a 4, 6, 8, 10, so on and so forth. So what I know about a square root is that my what I have inside here, I don't really care what it is and how it appears. What I know is that my x squared minus y squared should be greater than or equal to what? Greater than or equal to 0. The square root of 0 is simply what? Simply a 0. Okay, but we are not allowing anything below 0, meaning we can't have a negative. Okay, because we know to say square root of a negative number such as that is simply equals to what? Simply equals to I, and we don't really want to work with complex numbers for now. Okay, so here we are saying it should be greater than 0. Okay, so meaning starting from 0 going above, we're okay. So this gives us the what? This gives us the domain. So how can we write it? We can say, okay, you can write inside build notation the domain. You have that of x comma y. We do that, then your x squared minus your y squared should be what? Greater than 0, and that's our domain right there. Then what about the range? How you get the range is that you just need to ask yourself this question: what's the lowest number that can I get from this? Okay, the lowest number that we can get from that is a what? It's a 0, and it's included. Okay, it's a 0. That's the lowest number that you can get. You can't get anything below 0, but can you get anything above 0? Yes, you can. And is it limited? No, it's not limited, meaning you can go as far as positive infinity, and that is the what? That is the range, like that. Okay, let's look at another example. Let's say we are given um let's say we're given, oh, by the way, maybe before I go to the next example, let me try to graph this to see what we are what how this is going to appear. Okay, so we had our f over x comma y. Okay, we say it was equals to we had x squared um, minus y squared, and that's like I'll raise it to 1 over 2, 1 over 2. So that's what I have right here. Okay, so this is what we have. So you observe to say you have all sets of numbers, like for the y-axis and for the x-axis, but for the z-axis, like for the z-axis, we don't have anything down here. We only have values going on the positive side, of which value just start from this point, which is the 0, and it really makes sense that we found whatever that we found there. Okay, so let's quickly look at another example. So we'll try to be graphing so that we try to make sense out of this. So f of xy let's say is equals to square root of y minus x squared. Okay, so this is very simple. The domain, don't even need to waste time. The domain of x comma y, that would be like your y minus x squared should be what? Greater than or equal to 0. Then what about the range? The range, we know the lowest we can get is what? 0. The highest we can get is what? Positive infinity, and you are done, just like that. Okay, graphing that, I don't think I have to waste my time graphing this, because we graph something similar to that, and it's obvious this is correct. We'll try to graph something else that's maybe that's really a bit different, yeah, compared to this. So let's try to look at another example. So let's say we are given another one that is similar as well. F of xy is equals to the square root of x minus y squared. The domain for this one, okay, we have x comma y there. Okay, that would be like your x minus y squared should be greater than or equal to 0. That's our domain. The range, you are right. You got it right. I believe you thought of this. 0 to what? Positive infinity. That's the range. So what about let's say we're given something that is slightly different. Something that is a little different. This is the fourth one. Yeah. So let's say our f of x y, let's say it's equals to, it's a rational expression, root of y minus x squared divided by 1 minus x squared. Okay, so now for me to get the domain, I need to look at what is happening on the numerator as well as the denominator. Do I have any value that might make the numerator to be invalid? Yes, I have. I don't want to get a negative. So meaning it's a thing whereby, let's say for example your y is equals to 1, then your x is equals to what? Is equals to 2. You're going to find that if you substitute, you're going to get something like what are you going to get? You're going to get something like let's say 1 minus x squared, which is 2. 2 squared is a 4. Then divide by 1 minus, that's like that's still a 4. You're going to get square root of negative 3 divided by negative 3, like that, of which this is a complex number, and we don't want to do with complex number for now. So meaning we are not only going to focus our attention on, like, when you're finding the denominator, I mean the domain on the denominator. No, we'll look at both the numerator and the denominator. So it's that thing whereby anytime you see a rational expression, ask yourself, okay, on the numerator, do I have anything that might make my numerator invalid? If I don't have, then you don't really care how it turns out, whether positive, 0, or negative. You don't really care, but for now we care since it's a radical expression. Okay, so we are saying for the numerator, our y minus x squared should be greater than what? Greater than 0. Then for our denominator, our 1 minus x squared should not be what? Should not be 0. Okay, so now how can we simplify this? So this can be like our x squared should not be positive 1, meaning our x squared, oh no, no, not x, I can say my x should not be negative 1 and what, and positive 1. If you replace with negative 1 here, you're going to get a 1. Place with 1, you're still going to be a 1 there. So meaning our domain, um, I believe this is okay writing it like this. Our domain, our x should not be um, negative 1 and 1. Then let me say comma y minus x squared should be greater than 0, like that, greater than or equal to 0. That's the domain. Okay, what about the range? So now, since we know that the numerator will only give us positive values, okay, positive values, and on the denominator we know to say no matter what we do here, let me not be quick saying this. If I were to look at whole numbers, okay, whole numbers such as 1, 2, 3, 4, like all those numbers, like if you substitute here, you find that you're going to be getting a negative, because you're going to start substituting here with numbers starting maybe like starting with like maybe 0. 0 can work out, yeah, 0 can work out. Let's say 2 can work out. 4 can work out as well, but again, when you look at the numerator, meaning your y needs to be greater, because the value of x that you substitute for the numerator, that's the same value of x you substitute for the denominator as well. So here you can almost be tempted to say you only get negatives on the denominator, such that the overall is a negative number, but that would be wrong. Imagine if we say, okay, let's pick 0. Okay, let's pick 0. If our, let's say our y is equals to um our y is equals to 1. Okay, our y is equals to 1. Let's say then let's say our x is equals to what, uh let's say our x is equals to 0. So meaning you have something like 1 minus 0 divided by 1 minus 0. This is squared, that will give us a 1. We get something positive. But you observe to say, like, from 0 going this side and from 0 going this side, if you pick 1, I mean negative 1 this side, and you pick 1 here, and if I keep on going, let me pick negative 2, I pick positive 2 here, you find that when you substitute here, you're going to be getting negative, you're going to be getting negative values on the denominator. But the fact that we still have a chance of getting positive values, what we are going to do is that we are going to say our range, okay, our range there is just a set of all real numbers, because it's possible to is it, can we say it's possible to get it's possible to get a 0? Yes, it's possible to get a 0. If we set our y to be equals to 0 and x to be equals to 0, be like 0 divided by 1, which is going to be a 0. So it's just a set of all real numbers. And is it possible to get a 1? Yes, it's possible to get a 1. Okay, so that's simply the range. The range is just a set of all real numbers, like from negative infinity to positive infinity. That's the range. Okay, so let's try to look at another example on determining the domain and the range. Okay, let's try to work with conic sections now. So f of xy is equals to, let's say it's a square root of 25 minus x squared minus y squared there. Okay, so what we know is that from the, like, this is a radical expression. So for the domain, we know that our 25 minus x squared minus y squared needs to be greater than or equal to what, 0. So we can say our x squared minus y squared needs to be greater than what, greater than or equal to 25. Wait, not minus, supposed to be plus. So x squared plus y squared needs to be greater than or equal to what, 25 here. So that's simply our domain. So I can say the domain, you have like your x comma y, then your x squared plus your y squared needs to be greater than or equal to 25, like that. So now What about the range? So you, since it's a radical, you'll be like, okay, the lowest I can get is is a zero, the highest I can get is infinity. It's so easy to make that mistake. But what we know here is that when you try to make an observation here, the lowest you can get, okay, the lowest you can get here is a zero. What do I mean by it being a zero? Let's just say our x is equals to 5 and our y is equals to 5, for example. Okay, so what is it, what is really going to happen here? So if we say uh 25 minus 5 squared is 25, is this really going to work out? No, 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 no. That can't work out, because that would give us like 25 minus 25. That would give us minus 50. So that is not valid when you look at the domain. Okay. So now let me begin by using this example. Maybe let me say my x is equals to 0 and my y is equals to 0. We have 0, 0 there. What is it going? What you're going to have is the square root of 25, which is simply what? Which is simply a 5. So the thing is that when x and y are as low as 0, the value that we get is the highest value, which is 5. Okay, that is what it means. Then there can be a situation whereby your x squared plus your y squared is equals to 25, such that if this is equals to 25, meaning you have something like 25 minus 25 giving you what? Giving you root of 0, which is what? A 0. So what it means is that for this one here, this is our highest value and that's our lowest value. So for the range, is simply, it runs from 0 to what? To From 0 to 5. Okay, we're including both 0 and 5. So let's try to graph this so that we see what this is all about. Okay, that's 1 over 2. So this is 25 minus that. Okay, is it like that? Oh, okay, let me just say we have our f and x comma y. Let's say this is equals to we have our 25, okay, minus x squared minus y squared there, and you raise this to the power 1 over 2. Okay, well, this was very small, but we can make it bigger. Okay, so now this is what we have. So this is like a circle whose radius is 5. Okay, whose radius is 5. So it's more like we have like 5 at this point, negative 5 in the y, we have positive 5 here, we have negative 5 here in the x, and we have positive 5 on this side in the x. Then at this point, okay, at this point, this is also a what? This is also a 5, and that simply tells us how high we can go. Okay, so that's simply how you analyze that one. Let's try to look at another example where that involves a conic section, but one that is a little different. Let's say an ellipse in this case. Can we say an ellipse? Let's say we don't know for now. It can be a parabola or hyperbola. So let's say it's a square root of let's say 36 minus 9x squared uh, uh, that's supposed to be plus or minus. Okay, let me just use minus here, 4y squared. Okay, so one thing again that we know is that our domain, we don't even need to waste time for such. Our x comma y, then that would be like your 9x squared plus 4y squared needs to be greater than or equal to what? 36. Greater than or equal to 36. And that's our domain. Then for the range, once again, this is very easy to conclude. The lowest we can get is 0. The highest we can get is a what? Is a 6. Okay, the highest we can get is a 6. So what it is here is that even if you were to graph this, we are still going to observe that the highest we can get is still 36 there. I mean, what the highest we're going to get is 6, not 36. So you say 36. What do we have here for x? That's 9. Then here we have a 4. Okay, we say 36 minus 9x squared minus 4y squared there. Okay, then we say to the power 1 over 2. Okay, that's what we have. Something like that. So the highest we are still getting for this part is, we can see that it's still what? It's still 36 at that point. Okay. So now let's try to look at I guess 2 more examples. Okay, so now let's say we have our f x comma y is equals to, let's say we are given ln of absolute value of 36 minus 4 x squared plus 9y squared, like that. So now this, we know to say for natural logs, we are not supposed to get, we are not supposed to have a negative or a 0. So now when you have that in mind, to say you're not supposed to get a negative or a 0, you try your level best to do anything, avoid doing anything that might that might result in you getting a 0 or a negative. So in this case here, we might get a 0, yes, but a negative, we don't really care if we get a negative or not, because we have these modular signs. They are going to cancel out the negative. So it basically means for the domain, okay, for the domain, how can I write this? Okay, for the domain, I'll just say the domain, since I'm only avoiding 0, says x comma y, my 4x squared minus 9y squared does not, we don't need this to be equals to what? To be equals to 36. Okay, that's our domain. So meaning we're only avoiding this being equals to 36, but it can be anything. It can be positive, it can be negative, and if it becomes 36, meaning you're going to have a 0, and we're only saying this because you're trying to avoid a 0. What about the range? The range is obvious. We're just going to be getting the lowest we can get for a natural log is a 0. Okay, the lowest we can get is a 0 there. Why? Like, how can we get a 0? That is if we have ln of 1. That's how you can get a 0. Then the highest you can get is positive infinity. Okay, unfortunately I won't graph this one. You can try it out. So let's say fx comma y is equals to the square root of xy. This is very straightforward. The domain, how is this going to be? Yeah, you thought right. Our x y needs to be greater than or equals to 0. Simple as that. The range, the lowest we can get 0, the highest is infinity, and that's simply how you go about determining the domain and the range of the function that is given. It's just a matter of you understanding what the domain is. If you understand what the domain is and how to relate it to the range, it becomes much easier to solve such questions. So that's all in this tutorial. Thank you very much for watching.